Welcome back to AP Stats Notes Online. I want to pick up where we left off at finishing up section 8.2. We're talking about creating a confidence interval to estimate a population proportion. And we've kind of gone through all the steps at this point. It's just a matter of sort of putting it all together. We'll also go ahead and talk about, maybe you have a desired level of confidence and you want to know before you start sampling how big your sample size needs to be in order to come up with a certain margin of error. A situation that I've been in personally that I'll allude to when we get there. Okay? All right, so the four-step process. And so on the AP exam or even for practical purposes, you're going to want to make sure that you go through, especially if you're doing something somewhere out in the real world and you have to come up with a confidence interval and you want to write up a report. There are certain things that you're going to want to make sure that everyone in the world knows when you go through and do your confidence interval. So we do our four-step process, our state plan do conclude. And so on the AP exam, what they'll do is they'll give you some information and they'll either say, construct a one sample Z interval or one sample T interval, and we'll talk about T later, to provide evidence. Or they'll just say, come up with a set of plausible values for the population parameter, use appropriate statistical methods, or something like that. So anyway, we want to make sure that we're including all the work that we need to earn all the points that we can. And for practical purposes, you want to make sure that you're conveying everything that you need to convey to make your interval critique proof, right? You don't want anybody to be able to come back and say, yeah, but did you do this? And yeah, is this? So you want to make sure that you're communicating everything that you need, okay? First step is state, right? And so we want to do that. What parameter do you want to estimate and at what confidence level? And so it might be something like, I want to estimate P, which is the proportion of blue cars, or whatever it is, at a 95% confidence level. Okay, something like that. And we'll get to a specific example in a second, right? But you want to make sure you define your parameter that you want to estimate and at what confidence level, okay? Once you get into a situation where you're planning out your interval, the first thing you want to do, and this is going to be true even when we hypothesis test, when we're doing hypothesis testing, is identify the appropriate inference method. What are we doing? Right? I'm doing a one sample Z interval. I'm doing a two sample T interval. I'm doing a two sample T test, or I'm doing a chi-squared test. You always want to identify your inference method. And then you want to go through your conditions check, and I've talked about that at length, right? Literally write out normal, random, independent, and make sure you talk about how all those checks are good to go. And then we're going to do it, right? If the conditions are met, we're going to perform the calculations. That's going to be the easy part, right? Now that we understand how to find this critical value, the Z star. And then any good statistics problem ends with a nice conclusion, and you want to interpret your interval in the context of the problem, okay? In the context of the problem. Now on the Give Me a Kiss activity that you guys will get back soon enough, when you're concluding your interval, you want to make sure you're careful about your context. You want to go back up and pull context from your state step, right? What is it that you wanted to estimate and be specific, okay? All right, so that's generically what we're going to do. And we'll take a look at an example problem in just a second to see exactly how to do it. Is it okay to use your calculator to calculate the interval? Absolutely, and I'll show you how to do that. The section 8.2 in the book has a yellow section in that in the text that'll walk you through how to use your calculator also. A couple of things to keep in mind, okay? One is multiple choice questions use the formulas, and when they come up with the intervals, they'll use the intervals. The 5 choices will be intervals that have been created from from the formulas. Okay. What they'll also do is they'll make some answer choices like A, B, C, right? And they'll look like this. There'll be something like 0.26 plus or minus 1.645, and then they'll plug in whatever. Actually, it would be what, 0.26 times 0.74. Don't worry about where these numbers are coming from. I'm just kind of making them up. Over 200, right? And they'll plug that in. So you need to understand what the formula looks like, even if you're using your calculator. The other issue you run into, we talked about before, if you just use your calculator and you don't show any other work, you won't receive partial credit on the AP exam. And for that reason, I want to see the formula on all of your work in here. On tests in here, I want to see the formula. You are graded on partially on showing your work in here, and that's just because I'm trying to get you to learn it. So make sure that you show the formula. But you can still use your calculator to come up with your actual interval. Okay? All right, let's take a look at an example. According to an article in the San Gabriel Valley Tribune, most people are kissing the right way. Okay? That is, according to the study, the majority of couples tilt their heads to the right when kissing. And so all of you about this time are starting to imagine what you do when you kiss somebody and if you're tilting your head to the right or not. Okay? It might be what you think about for a little bit anyway. You shouldn't be kissing anybody anyway. In the study, a researcher observed a random sample of 124 couples kissing in various public places, which is, not creepy at all. Staring at people while they kiss, and found that 83 out of 124 of the couples tilted to the right. Okay, even more creepy is that they're watching someone kiss and then writing stuff down. Anyway, construct and interpret a 95% confidence interval for the proportion of all couples who tilt their heads to the right when kissing. Go through your 4-step process. Right? What would that look like? State. Okay. This is one example of how to word this, right? Using a 95% confidence level, we want to estimate P, which is the true proportion of couples that tilt their heads to the right when kissing. There's your context that we're going to use in your conclusion in just a second. Okay? All right. Plan. Okay? And so you're going to literally write these things out. Okay? One is, all right, I'm going to use a one sample Z interval. Why one sample? Because we only have one sample of 124. A Z interval because our critical value is a Z score. So that's why we call it a Z interval. Okay? And there is a difference. A T interval, which we'll talk about what sample means, comes from a critical value that's created from what can be called a T score. It comes from the T table, another table in your formula packet. All right, and so it's a one sample Z interval for P. Okay, and so we go through random sample. It said random sample, so it was stated, and so that condition has been verified. Okay, normal approximation, right? The n times p hat and n times 1 minus p hat is where that normal approximation comes from. Is our sampling distribution going to be approximately normal? Well, you don't have to actually go through n times p hat, right? Our successes, 83 couples tilted their head to the right, so that's our number of successes. Therefore, 124 minus 83 gets us our 41, so both of those are bigger than 10. Good, checks out. And then independent, right? We want to make sure that each observation is independent of the other. The probabilities that do not change too much. So we need more than 1,240 couples to exist. And so that's going to be an assumption we make. We assume the number of couples in the population is more than 1,240. And I think that's probably pretty safe to assume. Okay? So everything's ready to go. We're ready to rock and roll here. All right? Now, to show your work, okay, You're going to come up with the formula first. Now, if you don't write the generic formula, p hat plus or minus z star square root of p hat times 1 minus p hat all over n, that's okay. But you got to at least show the numbers broken out in this way. Okay. So our point estimate, our p hat is 0.669. So it comes from here. And then our critical value comes from our confidence level, so 95%. If you need a reminder of where the 1.96 comes from, come see me and we'll talk back through it again, okay? But your critical value is always going to be 1.96 for a 95% confidence level. And then square root of 0.669, and then if you want to do 1 minus 0.669 here, you can, or you can just make this 0.331 and be fine. That would be fine too. Divided by 124 and then square root all of that. At which point you can write your interval out in this format, or you can write your interval out in this format. Either one is fine. You don't have to do both. Either one is fine. Okay? But to show your work. Okay? Again, in a second, maybe we can do it this problem. I'll show you the calculator functions. Okay? So now we need a good conclusion, right? And so in context, we are 95% confident that the interval from 58.6% to 75.2% captures the true proportion of all couples that tilt their head right when kissing. And you know, if you notice, a lot of that stuff comes from the definition of P up here. So we want to make sure you bring that down. All right? That's it. Your 4-step process from beginning to end. All right? Now, calculator function. I promised I'd show you that, right? And so I'll do that and try to do that in a smaller square. Okay? Yeah, we'll blow it up. So if you have your calculator, you can pull that out now. You may stop the video and pull it out. But anyway, all of your inference procedures are going to be under stat calc. Sorry, not calc, stat tests. This is where all of your tests are going to be. It's your stat menu, your stats menu. And we called this a one sample Z interval. Okay? And if you go down through and cycle through all of these options, okay, there are a lot of options, and so we want to choose the one that we want. It doesn't sound right, like a Z interval. We have two sample Z and T intervals, but we want a one proportion, a one sample Z interval. So we want this guy right here, a one prop Z int. And you hit enter, and it's going to ask you for some stuff. Okay, it's going to ask you for your number of successes. And in our particular example here, our number of successes were 83. It's going to ask you for the sample size, which is 124. And it's going to ask you for your confidence level, and we're at 0.95. And then when you hit calculate, boom, it gives you the interval there. So 0.586 to 0.752, you can compare that to what your notes say right now, and it should be the exact same, just rounded. It does give you your p hat, and so once you go through and compute the interval on your calculator, that could help you in filling in the parts of the formula. You're going to need p hat in your point estimate in the formula, okay? And then, of course, it shows your sample size there. So pretty easy, pretty straightforward. Just remember that's in stat tests, and we want one prop Z interval, not the other imitators. Okay? All right. Then let's keep moving on. Okay? And talk a little bit about choosing your sample size. And so I told a couple of, I've mentioned this story before, and so I'll quickly say it again. I was faced with this. My mom working for an ophthalmologist who wanted to report a success rate for his laser surgeries within a certain margin of error, but he didn't want to have to go through and pull all of his results. And so my mom called me, asked me, how many files they need to pull in order to be able to create this statistic that he wanted to post on his website. And so I did this calculation. I asked some questions, how confident, what kind of confidence level. I had to explain that a little bit, and that kind of thing. And based on that, I was able to do some calculations and helped her figure out that, they're going to have to pull so many files that they're well above 10% of the population and pretty close to the total number of files. So they might as well go ahead and just pull them all. So very worthwhile sort of conversation here, okay? So choosing the sample size. First of all, what's the formula for the margin of error for a confidence interval for a proportion? Remember, margin of error is all of that stuff that comes beyond the plus or minus in your confidence interval, okay? So that formula looks like this, and MOE is margin of error, okay? And so what we write out is margin of error is greater than or equal to Z star square root of p hat times 1 minus p hat all over n. That's the second half of your confidence interval. Now, why greater than or equal to? Because we want our margin of error, again, we want our interval to capture our population parameter. We want to make sure of that. So we want our margin of error to be at least a certain amount. It's a more conservative approach. A larger margin of error would just create a bigger interval, and we would be more likely to capture the population parameter. So we set this greater than or equal to for that reason, okay? And so that's what we're going to get into. So how do you choose the value for p hat when solving for the sample size? Because again, this is something that you're going to do prior to your sampling, right? You're trying to figure out how many you're going to have to sample in order to get a particular margin of error, plus or minus 3%, plus or minus 5%, or whatever it is that you want to do. So we have to have a p hat in our calculation. And if you're, for this class purpose, if you're not given one, we're going to choose one. In practical purposes, you're not, unless you're, piggybacking off of another study that had a p hat, you could obtain an existing p hat from there, or you're just going to understand that you won't have a p hat. So if we don't have one, we're going to use 0.5, okay? And why 0.5? Because again, we're always looking for the most conservative approach, and in terms of doing this calculation, obviously the bigger this is, or the bigger this is, the bigger this is, the bigger the sample size is going to have to be to offset that growth, if that makes any sense. So if you go through and multiply different combinations of p hats and 1 minus p hat, you're going to find that 0.5 times 0.5 is the biggest product combination that you'll get, which is going to be 0.25. So that would make this number bigger than any other combination of p hat and 1 minus p hats. So that's why if we don't have a p hat, we're going to use 0.5, right? That being bigger means that our sample size is going to have to be bigger, and it's a more conservative approach, okay? So if you're not given a p hat, just use 0.5. All right? That being the case, we can get to an example here and go through and figure out how to get to that calculation. So suppose you wanted to estimate P, the true proportion of students at your school who have a tattoo, with 98% confidence and a margin of error of no more than 0.1, right? You want to be within 10% either way, okay? How many students should you survey, okay? Well, 98% confidence suggests its own critical value, Z star. And since we haven't taken a sample, we don't know what our p hat is yet. So we're going to start with our formula, margin of error, greater than or equal to Z star times our radical here. Well, our margin of error that we desire is 10% or 0.1, so we're going to put that there. Our critical value should be 2.33, And you can work through a 98% confidence level to find that critical value if you want. There should be 2.33. And then we're going to plug in, again, we don't have a p-hat, so we're going to use 0.5, and then 1 minus 0.5 is just 0.5. And again, it gives us a more conservative approach. Okay? So, how to solve this? And there's not a lot of detail in this, and just, we're not in the practice of doing a bunch of algebra in here, but it just becomes an issue of getting n by itself. And so I'll offer up my own sort of method here. First thing I want to do is get rid of this 2.33, so I divide that into both sides. And then we end up with this. 0.5 times 0.5, like I said before, is 0.25. I'm just going to go ahead and replace that there. Now I'm going to square both sides, so you get this. Okay. And then through a series of cross multiplying, you're going to end up with 0.10 divided by 2.33. This is all going to be squared. N greater than or equal to 0.25. And then you got to divide this whole mess to get n greater than or equal to 0.25 all over. And because we're just going to type this into our calculator, I'm going to write it out even though it's not good mathematics. Okay? And then just type all of this and make sure you're following order of operations. And my guess is you're going to do some of these in steps. So divide 0.1 by 2.33, that's going to be one step. And then square it, right? And then take 0.25 and divide it by whatever you get when you square that quotient. And that will give you your n. Now, when you do that, you should get, within some rounding error, rounding differences, 135.72. So n is greater than or equal to 135.72. That's how big your sample size needs to be. Now, obviously, you can't sample 0.72 people. So again, a more conservative approach is to go ahead and round your sample size up, right? Always round up. And again, it's because a little bit bigger sample size means your interval is going to be a little bit bigger and more likely to capture the population parameter. So always round up. At 98% confidence, and a margin of error of at most 10%, right? We need to survey at least 136 students to estimate the true proportion of students with a tattoo. Okay? We don't want any more than 10% margin of error. Okay? And so that will get you in some idea as to how many people you need to go talk to. All right? That's it for tonight. That gets us through section 8.2. We are going to be ready for a quiz. Look forward to that coming very soon. Have a good night. There is homework in the text. Feel free to start on that or wait until the next class period.